Close your eyes.
I'm going to hang up this phone, and then I'm going to show these people what you don't want them to see.
This world is not what you think it is. This world is not what you think it is.
Close your eyes.
All right, we should be live. Stand by here for a second. Yeah, we should be live. So this will be cool. I don't know who's out there, but this is Robert Bassano, Robert Shortman. You guys know my motto. It's not what you know, it's what you can prove, right? So today we're gonna do a short one. No pun intended, Robert Shortman. I said short one, not Robert Shortman. But today's title of this brief hangout is called Layman's Perspective on Reality. I was going through some I put out, and I noticed something on one of the software programs I had pulled up, and it was interesting, man. And what Robert and I are going to show you today, because we were looking over this and we just thought it was funny. We got video commentary proof to back it up from one of the top theoretical physicists on the planet. Theoretical physicists. There's a few things we're actually going to show you guys. We're going to show you something also from NASA where we think they may have screwed up. And we don't mean screwed up like in a minor way, but in a factual way, where we might be able to show you where there's more land on the earth, okay? And it's in real time. So when you upload the software program, it actually shows you real-time view of it, okay? So let me mute this music here in the background. But what we're going to show you today is a layman's perspective of reality. Before we show this to you, what we're going to show you is this, is that according to science, okay, whatever the hell that may be, we have a limited technical capability of what we can see on a microscopic scale, okay? Meaning that we can only see things, observe things at small level, that anything beyond that is just theoretical, okay? We can't even confirm the shit even exists. So when we show you this actual illustration, I'm gonna pause it in the middle of it to show you guys something that I need you to pay attention to. And then we're gonna keep going through the presentation and show you the reality. If we can't see things beyond a specific point here on Earth, what fucking makes you think we can see anything point, but on a positive scale, out beyond our atmospheres, okay? So what I'm gonna do right now, because I'm not gonna be paying attention to chat, I'm gonna do this presentation for you guys. This is gonna be funny. And it was so obvious. It's like here we are looking for all these, you know, detailed technical documentation to show you guys all this, to break it down for you. And when in reality, you know, to coin a phrase, this shit's right there in front of us, man.
Let me know.
I mean, it's just,
let me know when you screen share, Robert, and then I'll let you know that it's come up as well.
Okay, yeah, I'm getting ready to do that. Yeah, I'm getting ready to do that right now. I'm getting ready to do that right now. So I'm gonna pull this up for everybody. I want everyone to see this shit because it's funny as hell. Okay. Let me know when you can see everyone can see the screen, Robert.
Yep.
Everyone can see it?
Yep.
Okay, perfect. So this is a software program. It was put up by two MIT students, okay? I think they're master's and PhD level students, but the title of this of this application is called Scale of the Universe. All right. Anybody who's got an iPhone, you can go to Apple iStore and download this damn thing so you can see it for yourself. Now, here's what I want you to understand. Okay. Before I play this, I want you to you're going to listen to Dr. James Gates. Dr. James Gates is actually a physics professor at the University of Maryland. I tried to call this guy, left a message, sent him emails. He hasn't gotten back to me yet. He's just probably so busy going around the country and around the world, continuing to push the bullshit that he doesn't even believe in, okay? Which is kind of ironic. But what I want you to pay attention to right now is I want you to see where we're starting from. We're starting from 10 to the minus 35.0. That's 35 fucking zeros right of the decimal point. Okay? Not left of the decimal point, but right of the decimal point. So that's 0.35 zeros, 10. Okay? That's how small a Planck length is. That's what they claim how small it is. That's what they're theorizing how small a Planck length is. But I want you to listen to Dr. James Gates when he tells us what our capabilities are to see anything. Okay? And what the level of what that level is. Okay, so stand by here for a second. Let me play this for you so you can all hear it. All right, here we go.
Basis. Well,
listen.
Well, first of all, we have to understand genetic here, folks, because obviously there aren't going to be cells out there giving rise to reality. But something rather similar to a code is really going to be our ultimate goal. So I want to talk to you about this strange code that research that I've been working on. So let's begin by taking a journey. We'll go down in size. We're going to do this by powers of 10. Each mark on this image represents a power of 10 times smaller than the previous one. So we're going to speed up at the beginning, going very fast past a lot of interesting chemistry, biology, condensed matter, and slow down at blood cells at around 10 to the minus 5. These are newly representations of newly emerging blood cells. They still have their nuclei intact as they leave the bone marrow. At 10 to the minus 9, we encounter strands of DNA. That's what it's all about. Learning how to read the code. And in fact, there's a code buried here. And this code we can think of as a book of life. This is what the code sort of looks like. If you actually were able to read off strands of DNA, find out it's sequences of letters A, T, G, and C. These actually stand for adenine, thymine, guanine, and cytosine, which are the base pairs that appear in the double helix as discovered by the Watson and Crick some years ago. The DNA, of course, is really interesting because it also, in addition to being a book of life, it's a book also of human history. DNA has revealed a wonderful story about how we are all intimately related to each other. Coming out of Africa some couple of 100,000 years ago and watching waves of humanity go out and populate the world. And so I like to say philosophers have been for millennia saying that all of us are brothers and sisters, but now we scientists can say it with much more force and vigor and with much more explicit knowledge than has ever been humanly possible before. That's the power of science to tell us who we are. So DNA doesn't stop the story. We can go to smaller scales. At 10 to the minus 10, we enter the world of the atom. This is a representation of the clouds of electrons around a typical atom. And of course, the atom itself is an interesting story. Part of it we see in this symbol. I think of this as the Mona Lisa of science. Almost everybody in the world has seen this at some point in their life. And it's a little bit mysterious, like that smile on the Mona Lisa. And yet it's so familiar to us. And so chemistry, this table given to us by Mendeleev, was in some sense a major breakthrough for our species in understanding the place in which we live. There's a joke about Mendeleev and the Tsar. I don't know whether it's true or not, but I'll share it with you. Supposedly, at some point gave Mendeleev a medal. And so I heard the story from Sergey Brin's father, who's a mathematician at the University of Maryland. And he said, so Jim, you know, the Tsar gave Mendeleev a medal. I'm like, no, I didn't know that. And he said, oh, yes. And I said, oh, the Tsar was so forward-looking. He said, oh, no. The medal was for the improvement in the distillation of vodka. We can continue to go down in size past the world of the atom. And about the time I was graduating from high school, this is a helium atom. We see two blue balls, so protons, two pink ones, neutrons. And inside of these smaller balls, we see smaller pieces of matter. They're called quarks. They were discovered about the time I graduated from high school in 1969. There was a series of experiments that were performed at the Stanford Linear Accelerator Center. They were called the deep inelastic scattering experiments. That's when we learned that inside protons, there are these little small objects, little balls inside a bag. And so you should think of the proton as a bag, but these things inside are even smaller and more fundamental. At this 18, because 10 to the minus 18 is the limit of our technological prowess as a species, we have no devices that can measure anything that is smaller than this limit. And so as we journey in this talk to ever smaller scales, because we will, you have to understand that these smaller scales are not accessible to us through the normal means of science, which is experimentation and observation. And so when I talk to the public about this kind of science, I always try to make sure that people understand that after we leave this limit, we're talking about what we think is the case. Suppositions, propositions. But they're based not on wild guesses. They're based on a very powerful set of eyes, a set of eyes called mathematics.
Now I'm going to stop it right there. I'm going to go back to what he said at 4 minutes and 1 second. He says our technological limit is at 10 to the minus 18. We can't see shit. We cannot observe anything and develop an experiment to prove it exists if it's beyond 10 to the minus 18. I'm going to let you hear that one more time, and then I'm going to show you what that looks like. Okay? We're going to go back to 4 minutes and 1 second and hear what he said. Okay? Listen, again.
10 to the minus 18 is the limit of our technological prowess as a species. We have no devices that can measure anything that is smaller than this length. We journey in this talk to ever smaller scales, because we will. These smaller scales are not accessible to us through the normal means of science, which is experimentation and observation. And so when I talk to the public about this kind of science, I always try to make sure that people understand that after we leave this limit, we're talking about what we think is the case. Suppositions, propositions. But they're based not on wild guesses. They're based on a very powerful set of eyes, a set of eyes called mathematics.
So I'll stop it right there. Everything we see that we assume exists beyond 10 to the minus 18 is based on proposition and supposition. What we think may be there.
Yep.
It cannot, he says there's no science or no technology that exists that allows us. We've reached our limit at 10 to the minus 18. Now, what everyone's looking at right here, right now, is 10 to the minus 35. So this shit here, quantum foams and strings, this is what they think is at this level. Almost twice the level below what we're capable of observing, okay? So I'm gonna go through this and show you guys how physics and how measurement, how our technological capabilities here on this planet. And by the way, that interview, that presentation was done in fucking 2012. Okay, 2012. Now, last I checked, and I'm heavily involved in advanced technology, supercomputing and high performance computing. And I'm gonna tell you here right now, I stay so up to date on this shit. There ain't nothing out there that exists right now or that was developed since 2012 that allows us to see anything beyond 10 to the minus 18. No fucking supercomputer, no supercomputer on the planet can observe anything and give you a simulation of what the fuck could be happening at beyond 10 to the minus 18. But we're gonna go through this, and I'm gonna show you guys something that is gonna blow your mind. Okay? Here we go. This is the experiment. All right? Hang on, let me give you guys a little bit of music here. Here we go. So here we go. Look down to the right-hand side. You'll see everything change from 10 to the minus 35 to 32. Keep going. And I'm going to show you something. You still can't see shit at this level. Now, I'm going to stop right there. These are neutrinos at 10 to the minus 24. Okay? 10 to the minus 24. That's 24 fucking zeros. According to NASA and every scientist out there who studies, okay, photonics and applied physics, material science, whatever it may be, whatever type of applied physics there may be, mechanical or classic, do not possess the ability to see neutrinos. We can't fucking see these things. This is just something we think may exist at this level, 10 to the minus 24. At this very moment, scientists claim that billions of neutrinos are being ejected from the sun at faster than speeds of light, faster than the speed of light. We talked about that in the last hangout we did, right? When we talk about superluminal signal transmission. Nothing is traveling at the speed of light. It's traveling way fucking faster than that. How fast? We don't fucking know. But scientists claim that neutrinos are traveling faster than the speed of light, billions of them, and they're screaming through the fucking layers of the atmosphere into the earth and right through your body as you listening to this hangout right now. You're listening to this broadcast and you got billions of neutrinos going through your building, your house, fucking concrete, steel, lead, whatever. That shit's going through your body right now into the ground. Billions of neutrinos. But they can never see these fucking things. They don't even know if they exist. Okay? They don't even know if they exist. Okay? But at 10 to the minus 24, this is what they're saying is going through our atmosphere right now. They're just guessing. He says they're not guessing, but he says that they can use fucking mathematics as eyes. Okay? They can't do the math. They can't do the math. I'm going to keep going. Here we go. That's a neutrino. Now keep going here. Hang on. High energy neutrino, bottom quark, charm quark, strange quark. Now I want to stop right there because at CERN they claim that the smallest they can get to is a quark. But right now we're at 10 to the minus 17.9. So let me go back a little bit. This is exactly where Dr. James Gates, the top theoretical physicist on this earth, okay? This is the guy who was writing about all this advanced shit. Guys, Brian Greene, Neil deGrasse Tyson, Nico Kaiku, all of these fucking guys. This guy wrote about code and strings back when he was when he graduated from MIT with his bachelor's pursuing his fucking PhD, okay? He wrote this paper over 20 years ago, I think 20 or 30 years ago. So everyone who's studying this shit now is basing it off of what he wrote about. They still can't debunk what it is he's saying, all right? So he's saying that we only have the technological capability to view up quarks and down quarks and strange quarks. That's what they can do at CERN. Anything beyond this shit, okay, when we talk about 10 to the minus 19, or let's just say high energy quarks at 10 to the minus 20, we can't see that shit. We're just thinking that there has to be something else there. Now, when I went through my physics course, we were asked the questions in my physics course. Is there any other measurable matter? We keep splitting electrons and protons and neutrons to eventually we can get down to the smallest possible level of matter that is observable. And in the class, 23 other students was this. It's a possibility, but eventually you end up with something where you probably end up with fucking nothing. Because if you take a piece of paper and you keep cutting down that paper by half, by half, by half, by half, by half, by half, and you keep doing that shit, right? Let's just say it's a bright yellow piece of paper and you keep cutting it in halves as best you can. You keep getting the finest tools you can get. Laser fucking laser cutting tools. You get it down to the nanoscale. You keep cutting it by half, by half, by half. Eventually, you'll get to the point to where you ain't even gonna be able to see the fucking thing to even cut it. So the question is, does it really exist? Okay, does it really exist? All right, you could say no, or you could say yes. There is no correct answer because you don't know. But at 10 to the minus 16, okay, let me go back here. Let me go back. At 10 to the minus 16.2, they are claiming that lengths shorter than this are not confirmed, meaning that if you go back beyond 10 to the minus 16, at 10 to the minus 17, you don't know what range of weak force is. They're saying that there's some sort of gravitational fucking force or some weak force that's keeping everything together. They don't fucking know. They don't know. That's the point of this.
Yep.
That's the fucking point of this shit. They say it right here, man. This is from MIT now. This ain't Robert Bassano and Robert Shortman. Lengths shorter than 10 to the minus 16.2 are not confirmed. They're just fucking guesses. This is what we think is beyond this point. We don't know. And if we keep going, and I'm going to keep going. Here you go. Now you can start to see protons and neutrons and helium nucleus at 10 to the minus 14.7, right? Electrons, chlorine, uranium nucleus, right? 10 to the minus 13. You keep going. A picometer. Look at that. Gamma ray wavelengths at 10 to the minus 11. A helium atom, a hydrogen atom, 10 to the minus 10. Smallest thing visible, look at here. Look what they say. The smallest thing visible to an electron microscope is a hydrogen atom and helium atom, right? Now, Robert, you want me to pull up that paper?
Yep, I'll do that now.
Let me pull up that paper. I got it right here.
Yeah.
Where was that section at?
13.
Page 13?
Theoretical design and control and simulation.
Okay, let me go to page 13. Yeah, let me go to page 13. Let me make sure everybody can see that shit. Okay? Was it chapter 13?
Yep. Next one down, there we go.
Was it this?
That's 14, yeah. Go up, yeah.
Wait, which section was it?
Number 13.
Did I pass it? Hang on. Let me see where. Oh, it was 2.2. Theoretical design, control, and simulation?
That's the one, yep. 2.2.
Or scanning electron microscope?
Yep. 2.2.
3?
Section 13.
Or 2.2?
So it's 2.2.
Okay, 2.2. 2.2, okay.
Yeah.
Go to that.
So one more down.
Okay.
That's the one.
Section.
There we go.
Which?
That's the one. Yeah. So.
Okay. This is it. Okay. So here we go. According to based on this, on theoretical design, control, and simulation, since nano-robotic devices have not yet been fabricated, evaluating possible design and control algorithms requires the use of theoretical estimates in virtual environments. Sharma et al. Discussed the use of molecular dynamics simulation in virtual reality in the field of bio-nanotechnology to help better understand the complex biological structures and mechanisms at the nanoscale. Molecular dynamics simulation is performed to help predict the dynamic performance of biocomponents such as proteins. Molecular dynamic simulation can help gauge the feasibility of particular conformation shape of a biomolecule through energy constraints. All right, let's see. Where do they go here?
Next one down, they also mention it again. At there,
Was it this one?
Yep, even though artificial nanobots do not exist yet.
Yeah, even though artificial nanobots do not yet exist, some work has been done in the study of coordination and control of large numbers, swarms of robots. Cavalcanti introduces a novel simulation approach intended for the research of nanorobot control design. The simulator allows for a virtual 3D graphical environment in which nanorobots can be placed and can interact with other nanorobots of their environment. The simulation locomotion of the nanorobots was based on concepts from underwater robotics. Okay? And then he says that they expand this simulation framework to investigate the design and control of medical nanorobots in a simulated blood vessel to treat stenosis. All right? And again, remember, what this shit comes down to, when you talk about electron microscopy, all right, they're saying conventional scanning electron microscope can resolve down to the nanometer scale, equal to 2 nanometers, whereas a light microscope can only resolve down to 200 nanometers. So they're using, this is the limitation right here.
Yep.
Of what we can look at. All right? Here on Earth. Here on Earth. Here on Earth. So let me go back.
The rest of it's imaginary after that, pretty much.
Yeah, the rest of it, they're just thinking, okay, something's got to be there. We just don't know what it is. So as I keep going here, right, I keep going out. The smallest thing visible in an electron microscope is a hydrogen and helium atom, right? So we keep going. So there's a water molecule right there. And we just keep going. Keep going. DNA visible at 10 to the minus 8. That's all right. We keep going. Ultraviolet wavelength at 10 to the minus 6. Violet light wavelength. A large virus can be seen at 10 to the minus 6. X chromosome 10 to the minus 5. White blood cells 10 to the minus 4.
They actually had a nanobot in there. If you zoom in on that, that's quite incredible. I just noticed that. You zoom in, it's called something biophage. Yeah, it's like some type of nasty nanobot that they can put in people. You zoom in, there it is on the right. There we go. That nasty sucker on the left, on the right.
Yeah.
Did you see him? They snuck that one in. Oh, they snuck.
Yeah, look at that
baby in. That thing up there. That's what they can use to put into people to do nasty shit.
Yeah, a bacteriophage. Yeah.
Yeah, but that's a nanobot type thing. 10
to the minus 6.
Yep.
We keep going. Red blood cells 10 to the minus 5.
That's what they say. Do you know what I mean? And you know, if they're kind of theorizing on a lot of things, it's what else are they theorizing?
Look, the width of the human hair 10 to the minus 3. The thickness of paper 10 to the minus 3. A dust mite 10 to the minus 3. A grain of salt. Fucking ant 10 to the minus 2. A grain of rice, pencil lead, coffee bean. Let's keep going. A penny 10 to the minus 1. Let's keep going. Human beings and giant earthworms 10 to the power of 10 at 0, right? Let's keep going. So now we in physical reality right here, right now. This is
Lunar Apollo. You got the Lunar Apollo in there. They have to put that one.
Yeah, the Apollo Lunar can be seen at 10 to the minus 1.
Yeah.
Now get this shit. They're trying to say that we can see that we should have been able to see the Apollo lunar module at 10 to the minus 1. That's here on fucking Earth. That's not on the moon. Average U.S. house. Let's keep going. Let's keep going. Oh, come on. Keep going. So again, I want you guys to remember that you couldn't see anything. Nothing could be confirmed at 10 to the minus 16. Okay? If you were at 10 to the minus 16, you couldn't see shit. 10 to the minus 18 is the furthest we can go. All right, so here we go. They're claiming that at 10 to the 6.9 power, all right, you can see the Earth, Titan, Mercury, the Moon, Mars, Io, Europa. I ain't never seen a Europa, okay? I ain't never seen Titan. I ain't never seen Mercury, all right? And look, they're saying you should be able to see all of fucking Asia at 10 to the 7th power, right? Asia. This is crazy, dude. This is crazy. We're going to keep going out because my point in doing this is this. If you can't see anything beyond 10 to the minus 16, we don't have the technology to see anything beyond 10 to the minus 18. Tell me how we somehow developed the fucking technology to see up into the sky, into fucking space, out in the universe, and they're claiming we can see shit that's light years away. Now I want you to get this, right? They're saying that 10 to the 15.7, that's one fucking light year. One light year. You should be able to see the Hourglass Nebula at 1 light year, right? We all know nothing's fucking traveling at the speed of light. So light years is bullshit. Ain't nothing a light year away. It could be right in front of your fucking face. You wouldn't even know it. So here goes 10 to the 18.1. They're saying we have the capability to see all this shit right here with telescopes. I don't give a fuck. And listen, I'm not talking about the telescopes they claim are in space. I'm talking about the fucking observatories on the fucking ground. Observatories on the ground around the world that they claim have the technological capability to see all of this shit right here. Keep going. Keep going. I don't know about any of you, but I haven't seen one fucking real photo from any observatory on Earth that shows me this shit right here. 10 to the 20th power. The Sombrero Galaxy. The Milky Way. The Milky Way is supposed to be 10 to the 21st power. The Andromeda Galaxy. The distance Earth has traveled relative to the sun. At 10 to the 21.9. 10 to the 22. Look at this shit. This is incredible, dude. They're saying we can see shit out this far. If we can't see beyond 10 to the minus 18 on Earth, how the fuck can we see? This is the observable universe. They're saying theoretically we can see all of this shit right here. That's where it stops. It stops at 10 to the 21st, 27. 10 to the 27. That's what they're saying.
I see, yeah.
People, common sense. Common sense, people. Common sense. Layman's perspective. Okay? Layman's simple perspective. If James Gates is telling us, okay, the top theoretical physicist on Earth just told us that our technological limitation, minus 18, we stopped right there. We can't, nothing else, everything is just, we think that there's something else beyond this, but we're really not fucking sure. So we got to use bullshit, stochastic calculus, and mathematics to tell you we thought of this shit. So yeah, all these quarks and these strings and this quantum foam, this shit exists at 10 to the minus 35. Well, guess what? I'm gonna go any further. Robert and I are gonna go further. Okay, we can be physicists as well. We don't need PhDs. Robert and I think, okay, maybe I'm gonna say it's me. Robert's gonna maybe assume something else. I'm gonna say I think I can go to 10 to the minus 100. And I think a whole nother fucking universe exists down there. I can't fucking prove it, but I'm gonna write a paper about it. And I'm gonna dare anybody debunk that shit. I'm not dare anybody to debunk it.
Yeah, I could go a few scales beyond what they're saying quite happily. Oh, yeah.
Dude, this shit is hilarious. I couldn't believe it, dude. I mean, when I looked at this, I'm like, wait a fucking minute. Oh no, this can't be real.
Yeah, it's really right.
You can see where they have to create virtual reality environments just to say, this is what we think may be occurring. This is what we may think is there. Ain't nothing there. Space is nothing but an empty, I don't know what the fuck it is. It might not even exist.
True.
Because based on what I found from the European Southern Observatory, where they shot a laser, a 22-watt laser up into the nighttime sky, and it hit of sodium atoms at 90 to 110 kilometers. The Kármán line supposedly is at 100 kilometers, right? Give or take. So when you look at the Kármán line, you got to ask yourself, wait a fucking minute. Something's not right here. No fucking way. If we cannot see beyond 10 to the minus 18, what makes you think you can see 10 to the 18? What makes you think we have the technological capability to see outward, but we can't fucking see inward?
Yeah,
I mean, I'm daring anybody. I dare anybody. I'll give you fucking $100. I have it transferred to your fucking PayPal. I dare any fucking body show me the documentation where we can see beyond fucking 10 to the 18 out into fucking space. Because if we can't do it on Earth 10 to the minus 18, damn sure. You better be damn skippy. We cannot fucking see beyond that.
Just imagine all the, you know, that distance they're saying they can look through, all that shit that would be in between that, you know, galaxies and, you know,
I don't give a
debris
shit.
and
They
shit.
say the
So much, yeah.
Yeah, exactly. They can say, oh yeah, the Hubble is out there 330 fucking miles, or Chandra is further than that. Fucking prove it. You're supposed to have shit out there taking pictures of the Earth. So that's for number one, the epic. Supposed to be taking pictures of the Earth from a distance, showing you a ball. Then if that fucking thing is out there, zoom that fucker in and bring it in closer and take a picture of fucking Chandra and Hubble.